Hello and welcome to the Cyber YouTube channel. My name is Ray, and in this video, part 7 of Fred's Left Hand, we're going to sort out the servo bed. But before we sort out the servo bed, what we should probably do is attach the elbow gear. Now with this one, I've actually printed this one in PLA. Been printed for quite a while now, and I worked out two spots where I wasn't going to cause structural interference, drilled some holes all the way through, then marked those same holes on the base, drilled those through. So it's this hole here and this one over here, and that matches up with these two holes. I then installed nutserts into these using a soldering iron, and that allows this to be mounted like so. Now the other thing I've done is I've also added all these pins and installed into one of these plugs. This is a 2x6 way, so 12 conductors, and I made up this short piece which is the same as this one but in the female version. I've broken out my power and ground wires. The two wires that I'm not using are down here, and the rest go into this plug or connecting to a Raspberry Pi. Now I have down here a Raspberry Pi 3 with my Robot Lab 1.1.850 running on it. It is connected to Discord and is running the program AB with Alispot in it. So that is live online at the moment, so you can talk to it if you like through the Discord channel. There is a link in the description below to that Discord. When you're in there, say hello to Fred online. So this just plugs in like so. This plug will go into the bicep when I'm finished and connect in to get its power and its data communication. Alright, so the reason why I needed to make sure I pulled the servo bed out first is because we've got these two screws to put in and we can't do that with these servos in place. So one of these holes is all the way up inside. See a screw poking out. And the other one is underneath the ribbon cable in here. Now the way this is normally attached, if you've printed it in ABS, this is normally positioned with acetone to actually cause a weld joint. Makes it very solid. In a PLA only build, some people will use super glue. I tended to plastic weld all the way around. Now in this case, this is PLA and this is PTEG. So they are dissimilar plastic, so I'm going to just rely on that one or two screw joints. Make sure that works. Okay, so this time round, we are going to install this drive shaft. Right down into the gear. It's located in the wrist. Right, so in the last video I actually fitted off the wiring, and I think in this video, in the description I'll put a list of the wire numbers, starting with these ones, the pink ones, which is our power, and I'll label what each wire does as we work our way through it. This then connects into here somehow, drops into the bottom. When our screw holes in there line up, we can put our screws in. this is no longer turnable as a result of connecting it to the servo. So to get that run right, we will have to reseat the gearing. And before I break anything, I will undo these screws so as to allow that to happen. You'll remember I left a little bit of slack on my communications cables for this reason. Let's plug in our servos. So this one is going to be for the thumb. I'm going to plug that into 0. How about I get the right ones? That's my thumb. And now's a good time to install this one. And before trying to put it in, I'll remove all these screws. Okay, so that's all our wires connected. So next trick will be to power up the servo so we can actually get them positioned where we need them before we connect the wrist. Okay, so the servos will need power. So I'm going to power this from my power supply running at 6 volts. The I2C bus is running at 3.3 volts. I've got power turned on. You may have seen that light come on when I turned on the power supply. No, that light came on when I plugged it into the Raspberry Pi. Okay, so when we're looking at the left arm, we want it centered this way. So let's first get this installed into my Robot Lab. Okay, so this is my Robot Lab running on this Raspberry Pi that I pointed out before. So what I should do is bring up my other camera. So now you can see the whole of it. Alright, so first thing we need to do is create a PCA 9685 entry for here. So if I have a look at the Raspberry, well actually first we need the Raspberry Pi. So I've created a Raspberry Pi entry. When I scan the bus, I get 70 and 40 is returned. 40 is the PCA 9685. And so is 70. 70 is actually a broadcast address. So if you've got multiple PCAs 9685s, you can actually send commands to all of them at the same time on that address. I don't think we've ever done that, and I don't think we will be doing that in any time soon. The next thing we need to do is create the PCA 9685. Now this is the Adafruit service. 16C servo driver. I called it PCA 9685. In the final build with Fred, it'll be left arm. We give it a name here, and then you click on Start Service. I've already started the service. Drop down, select the I2C controller that you have. In this case, it's the Raspberry Pi. If you're building this using an Arduinos, you can use the I2C bus on the Arduinos, in which case you would install the Arduino service, get that connected, and then you would connect this to the Arduinos. You select the bus number. For the Raspberry Pi, it's always bus 1. For an Arduino, it's always bus 0. And the default address is 40. I haven't changed the addressing on this, so it's also set at 40, so we can attach it. Once that's attached, we need to go back and create a servo service. In this case, I want to create one for the wrist, and it will be a servo. Just created a new service up here. Now it's not yet connected, so what we need to do is go into controller. Now, if you're running with an Arduino, you may choose to drive the servos directly off the pins, in which case you would select the Arduino. If built like this with a PCA 9685 in the forearm, you will need to select the PCA 9685. Select the pin that your wrist is attached to. In my case, it's pin 6. No, it's pin 5. And then attach. Now, by default, with a lot of the Inmoov stuff, auto disable will be enabled. This particular breed of servo has a bug, and the auto disable causes that bug to rear its ugly head, so we will leave it turned off. If you're ever using these servos, then be aware of that bug. This bug does not appear to affect any other brand of servos I've tried, such as the High-Tech, the Tower Pro, or the JX servos. Don't appear to suffer this issue. So we can go back to basic, because we did enable it, we're attached. Basic, rest. And we have live. Alright, so in the rest position, we want this to be like that. And then we try to realign these gears. There we have it. Okay, now it's recommended you have 300-degree servos. I've got 270s in, or a 270 in here. Alright, so our thumb, I'm going to bring back to this one, which is this wire or cable. There is a hole through here for our line to go through. This is the same as you would do if you were doing the original build. And now we need to set up the thumb. Left arm, pin 0, attach and enable. Basic. That's a rest position. If I rotate it back like so, that's about as far back as we really want to go. Pull the screw out. And feed through our cable, or our fishing line, I should say. Now I have had this in here before. Once you've done this a couple of times, it tends to fray your fishing line a little bit. It's down through the bottom side and come back up through this hole here. Fortunately, my super glue I usually use to make these a little bit more solid for feeding through has dried out a bit. So now we can put that back on there. I might just move this all the way. And I can wrap that around my screw that I've installed. That screw is a 1.7 millimeter. It's a coarse thread, it's not a metal thread, and it's 6 millimeters long. So now when we try and move our thumb, make sure the thumb is in the video picture. As far as I think I ever want it to move. So I'm going to actually, if you haven't seen it before, limits will open up these sliders. And I'm going to move this slider here back. And you'll see it operates the blue bar up here. We're going to set that to be our output limit. So you will notice that that has come back off. It means that we can't over tighten it now. So there's a little bit of tension on it, not much. And that I think is working quite well. Alright, we've only got 4 more fingers to do it. Some I want index. Now if I had small enough washers, I'd put a small washer underneath those to help clamp better. That bounced over. I think I might put these screws back in. Now there is another version of the rod ring that doesn't have, it doesn't connect directly to the servo, it connects to the servo horn. So if you use the metal servo horns, which you can get as a separate item on eBay, then you can get a bit more strength. That'll do me. Set our limits. Now you can adjust your rest position as well. So I can set rest down to here. And that works. When you're happy with your limits, you can then close that limits off. Now, I thought I created a middle finger, I did. Connect that to there. A little bit of pin 2, attach, enable, basic. Right, so, ring. My middle finger there, and it's all knotted up in here. Might go this side. Let's go back to here, invert, back to basic. They'll be all the way open. So I'll be pulling from that position, so I want to make sure that hole's big enough. I haven't created a ring finger. Okay, so that's all the fingers and the thumb tested. That'll do for this video. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. If you'd like to support the channel further, there is a Patreon account and a link in the description below. I'd like to thank my long-term Patreons, VIPs Go Lucky and Lorenz Berger, as well as my builder Patreon, Almorales45. If you'd like to talk to the chatbot running on this same Raspberry Pi as I've got in the video, you can find that in the Discord server. Give it a good test out. Link for the Discord server is in the description below, and we'll see you in the next video.